So we're just going to wait for a couple more minutes for everybody else to join in, and then we get started. By the way, for everybody else who just joined in, all the attendees, hi everybody, wishing you a very good evening. Just bear with us for a couple more minutes while we get started. We're just waiting for our registration or our signups to join in. And once they do, we will immediately sign you up and sign you in into this webinar and begin our discussion on this course. Hi, Cookie.
Hello, I'm sorry I'm a little late.
You're all right. We're just getting started. We're just waiting for a couple more attendees to join in and we can start. And for everybody who has joined us already, hi everybody, wishing you a very good evening. Thank you for joining us on a weekday. I am going to make sure 3 minutes is worth it. I'll introduce myself. I'm Praneeth. I'm the Associate Director for University Partnerships Worldwide, and in essence, the AD for upGrad Abroad. upGrad Abroad is super committed to ensuring that your higher education, especially when you're deciding or planning on studying abroad or studying outside India, is more democratized, more affordable, more accessible, more flexible. So we give you tons of options across the United States, Canada, Australia, the UK, Spain, Ireland, France, and Finland now to go and study while beginning from India, your online coursework, and then you finally get a credit transfer and move to whatever part of the world you want to move to. What this does help you is with making sure that you're more academically ready. The foundational skill set bolsters your chances at succeeding in the course, and that your learning outcomes are more expedited than you'd have for a usual admission if you were to take one. And finally, our model gives you a lot of access to different scholarships. Our model gives you a lot of access to a prorated fee that is generally lesser compared to the fee of a usual applicant into schools across the world. What we're doing with today's webinar is talking about this domain of artificial intelligence and machine learning, and how do you switch. How is this a very inclusive domain, and what industries can it actually add an impetus to for the future economic growth? As you may well be aware, we've got tools like ChatGPT. We've got an unprecedented division of labor between algorithms, machines, and human beings. And with that, it's not that jobs will diminish. It's just that jobs will change. It's just that a lot of you will have to adapt to technology, especially emerging technologies. A lot of you will have to be adept at mathematics. A lot of you will have to be adept at making or designing algorithms. A lot of you may have to be adept at deployment of technology to augment the task. Where does AI exactly fit? Where does machine learning exactly fit? Where does analytics, or where do analytics actually fit? So keeping all of that in mind and perspective, we have Dr. Dandekar, Dr. Nagarajan, Cookie, and Sherry joining us from Drexel University, Philadelphia. Drexel is one of the top 100 schools in the United States. Drexel is the third best engineering management course in the United States, and one of the top 10 or close machine learning engineering courses in the United States. And believe me, the US has about 4,500 schools. So being in the top 3 for an engineering management course or a machine learning course, the top 10 would really mean that they've got absolutely the right fit for the methodology, the infrastructure, the research, the faculty, all of that in order. But one of the biggest things about Drexel is that it's the #2 university across the United States for its co-op programs, next to Northeastern in Boston. So with that said, I'm going to give it to Dr. Dandekar to take it ahead. I'm passing the baton to him. But mind you, we're talking about AI, ML as a discipline of study. Why is it one of the most emerging fields? And I'm going to, for the first 15 minutes, I'm just going to keep bouncing off questions to Dr. Dandekar and the team at Drexel. and ask them to build more context on where does machine learning really fit across industries. One, how is an engineering course different to a typical MS AI/ML course? How does the machine learning engineering work differently? And number three, if this were to be a conversion course, is that an actual possibility for someone who's coming outside of the tech industry but is good at mathematics? How does this work out for them? So someone without academic background but a relevant professional background, how do they fit in this course? So these three things is what we're going to start with, and I will give the baton to Dr. Dandekar from here.
Sounds good. Thank you very much, and thanks for organizing this webinar, and it's a pleasure to meet all of you. My name is Kapil Dandekar. I'm the Associate Dean for Enrollment Management and Graduate Education in the College of Engineering. I'm also a professor of electrical and computer engineering. I've been at Drexel now for about 22 years, and definitely very glad to have a chance to tell you about our programs. I couldn't agree more with what Praneeth just said, that machine learning engineering is one of our most exciting new disciplines. And I think you'll see that while there's a lot of hype around the area and a lot of people are kind of going out and trying to use the tools that are there, it is a tool, and it is something that can be used as one of the many tools that engineers use to address real problems. So when we talk about our machine learning engineering program, and my colleague Professor Kandasamy discusses it, you'll see not only the foundations of machine learning, how the algorithms are put together and how they can be extended, but you'll also see some very exciting applications of machine learning engineering in different targeted disciplines, as well as the practical issues of how you make real hardware that's optimized to run these algorithms. So there's a big difference, I think, between what you can do, just as a casual user of machine learning, as well, versus a machine learning engineer, where you kind of understand those fundamentals, you understand the hardware, you understand the target engineering applications. So definitely very glad to have a chance to tell you about our programs. So I'll start off just in case you aren't familiar with an overview of Drexel University, and we'll talk about some of the plans of study that we have available through our partnership with upGrad. We'll focus in on our machine learning engineering pathway in this webinar, though we also have a pathway at engineering management if anyone has any questions about that. We'll also talk about some student life and graduate community at Drexel, discuss the application process, and then, of course, answer whatever questions that you may have. I'm very happy to be joined by several of my Drexel colleagues, and I'll ask them to also type their names into the chat window so that you know who's here, and certainly if you have any questions, we're happy to answer them. So let me start off with just a brief overview of Drexel University as a whole. This is a picture of our beautiful urban campus located in the heart of Philadelphia, Pennsylvania. You can see Drexel University in the foreground of the picture and Center City, Philadelphia in the background. Philadelphia is a great place to live, work, and study. As Praneeth mentioned, we do have a rich history at Drexel of cooperative education. For our undergraduate program, undergraduates can have up to 18 months of practical work experience as part of CPT integrated within their degree program. At the graduate level, they can have up to 6 months of work experience integrated within the MS degree program. Cooperative education is something that Drexel does quite well, and it really does speak, I think, very highly of the practically minded nature of our students and our programs, that there's this coexistence between coursework and cooperative education. Drexel is also known as a R1 research intensive university. This is the highest level of research activity, and this is something that we're quite proud of, since Drexel is one of the few private universities in the United States to have this designation. What this means for you as students is that our faculty are leaders in their respective disciplines. We have top-notch facilities that you wouldn't find at other universities, and there's lots of opportunities for you to get involved with that through laboratory-based coursework, to considering potentially a thesis, as well as seeing some of the cutting-edge applications of machine learning engineering, right? It's not just about learning the software for the software's own sake, but really being able to apply it to cutting-edge research problems. And if you look at our faculty, we have a number of researchers across the entire college who are really using machine learning engineering for exciting new engineering applications. And engineering really is the flagship college within the, Drexel University. We are a comprehensive university, but engineering really is the crown and the jewel, or jewel in the crown. So this is what where we're located. In case you're familiar with where Philadelphia and Drexel is located. So we're located in Philadelphia, Pennsylvania, which is located between New York City and Washington, D.C. on the east coast of the United States. We are an urban campus, as you obviously saw in my last slide. The cost of living is less in Philadelphia compared to other major U.S. cities. So that's something that you should consider as a student. Something else to consider as a student on our campus is that you don't need a car to get around our campus. Our campus is 1 block away from 30th Street train station, which is a major transportation hub in the US. So you can use subway, bus, and trolley connectivity to get to other parts of the city, as well as hop on a train and be in New York City or Washington, D.C. in a couple of hours. So it really is a nice place to live, work, and study, and it's been consistently ranked as one of the best student cities in the United States, according to QS. Drexel is on the quarter system. So when we talk about our machine learning engineering pathways later on, you should keep that in mind, that we're not talking about 16-week semesters, but rather we're talking about a quarter system where we have 4 10-week quarters where each quarter aligns with one of the seasons. For this immediate partnership, I believe we're considering mostly students who would be starting in the winter quarter, where classes would start in early January 2024. But we'll talk more about the application process and deadlines later on in the presentation. But this 4 10-week quarter system allows you to have a chance to take more classes than you might at other universities. Some of the classes are fast-paced, but this allows you to cover more topics. It also provides the flexibility that we need in order to integrate a potentially 6-month cooperative education as part of the MS program.
Dr.
Yeah, sure. Do you have some questions that you'd like to ask now?
Yeah, I just want to intervene and ask a few things that are on the
Sure,
top.
of course.
One of the things that I'd like to ask you is, how does a co-op really work for all of these students here who are attending this? Why is a co-op MS program better and more effective than one without a co-op? How does this benefit the student in the longer or the larger scheme of things?
Sure. Yeah, I'd be happy to answer that. So, so cooperative education is more than just an internship. It's typically a 6-month industrial job that's integrated as part of the degree program. It provides a couple of advantages. The first is that you're starting your job search and your professional development early in your MS program. Unlike other places where you might be walking across the stage at graduation and thinking you should meet someone in the career services office, at Drexel, when you participate in the co-op program, you take a co-op 500 level class at the beginning that introduces you to our Steinbright Career Development Center and all the various resources that students have available to help them find not just a co-op, but a full-time job after they graduate. So you'll learn how to write a resume, you'll learn how to articulate your career goals, vet your LinkedIn profile, leverage various resources that are available, online, lists of employers, alumni databases, career fairs, various resources that are available. And certainly if students have their own connections, it's very easy to get those companies added as co-op employers for the program. So, so that kind of building that professional network is something that graduate co-op does very well, but also it really enriches the educational experience that the students get, because they'll be taking classes to start in the program. They'll be getting some of that foundational knowledge, and then they'll actually go to a co-op where they have a chance to apply what they're learning in the classroom. And we've actually designed our curriculum in particular to help prepare people for that transition, right? They're learning the skills that they're going to need in industry. And then once they have those skills, when they come back from a co-op, they actually can bring that back into the classroom. And when you start taking some of the application level courses that I mentioned, that can be informed by the practical experience that the students have on co-op. So, we encourage students. Sometimes people think of Drexel as being only a cooperative education school, where they only think about the CPT employment. But we really encourage you to think about it as an integrated experience. You're taking classes, you're getting the foundational knowledge, you're seeing where the real problems are when you go on co-op, and then you're also coming back and feeding that into the rest of your curriculum.
Got that. One more thing which I want to know is, and I think I just like to give a little bit of context here. So upGrad Abroad has partnered with Drexel University, Philadelphia, for two major courses, the MS Machine Learning Engineering and the MS Engineering Management. So both of these courses, the base program of the start program can be covered in India online while you're still working, while you're still at a job. You don't have to immediately quit. That's the IIIT Bangalore Advanced Certificate Program in Data Science, or the IMT Advanced Certificate in Management if you were to do the engineering management course. But specifically for this machine learning course, you've got IIIT where you start, you do an 8 months graduate certificate, you immediately move to Drexel, and then you start the machine learning engineering. But your coursework comes on by almost 2 terms. You get almost 5 courses waived off. That essentially means about 2 terms are waived off. So essentially 20 weeks of study, more or less about 5.5 or 6 months of studies are waived off because you covered that coursework in India. In regard to that, sir, I just wanted to know from you, for students in India who are interested in an MSc-ML course, and for students who we want to inform that, hey, how is machine learning engineering address a different audience altogether? What are the possible career progressions? And could you draw a contrast between what would a typical MSAI holder study and land in or land at, and what would an MSML engineering student study and land in? What kind of progressions in terms of contrast? And what is the curricular difference in both?
Sure. Yeah, I mean, I can ask that and start to answer that, and I'll ask Professor Kandasamy to join in as well. So these are, as you mentioned, depending upon which pathways we're talking about through our program, we will accept a transfer credit towards our machine learning engineering and engineering management program, which will reduce the amount of time and cost that you'll have at Drexel working on these classes. Naga, do you want to answer some of the questions about the curricular aspects of machine learning?
Sure. Can we go to, say, the next slide? Or
sure.
Oh, yeah. So one back. Hello, everyone. So my name is Naga Kandasamy. I'm a professor in ECE and interim department head of ECE as well. So in terms of the machine learning engineering program we have, so that's a list of faculty who are both doing research as well as teaching in the area of machine learning. So just to give you an idea of the broad coverage of machine learning related activities at Drexel. Right? So Bill, if you want to go to the next slide, and I'll point out some aspects of machine learning. So in terms of the prerequisites, we've looked at what you would have had when you apply to Drexel and decide to come here. So essentially the prerequisites at this point are applied math and statistics, a little bit of data analysis, and introductory probability, which I believe the prior program should get you prepared for that. And we would also like all of our students have computer programming, especially Python, because our front ends to a lot of the machine learning tools are written in Python, right? TensorFlow and Keras model. So those are the 2 basic prerequisites that we would expect students coming in. Now, in the next slide, not yet, but we do have a pathway for students who want to take a little bit more statistics and data analysis before taking our classes. That's fine as well. But if you have those two prerequisites, I think that should be good for now. Now, why would you consider machine learning engineering? Almost every company in the United States has a team working on machine learning for data analysis. Philadelphia in particular, there is I believe Philadelphia is one of the largest kind of health hubs in the country in terms of genomics, in terms of gene therapy and cell and tissue engineering. We also have large corporations like Comcast. Comcast is the largest internet service provider in the United States. So I'll give you a specific example. Machine learning is now increasingly used to analyze network data, right? For anomalies, the malware detection is now moving to machine learning. So virus detection, for example, in the past used to be signature-based. So you take a file, you compute a signature, and if the virus has infected the file, the signature would be different. And you would say, okay, the file has been corrupted. But these days, a lot of companies, malware detection companies like Comcast, for example, are starting to use machine learning in real time to look at the data streaming in from the systems and looking for anomalies, for example. There's a lot of interest in healthcare, in the healthcare companies in terms of analyzing data, analyzing images, for example, tumor detection and things of that nature. So we also have a robust aerospace industry in this region as well, Lockheed Martin, Raytheon, and so on and so forth. Power industries also are looking to use machine learning to analyze, the performance of the power grid and detect anomalies. So in a nutshell, machine learning is used. Every single company to some extent has a group that does machine learning, simply because that is the standard way now that people do data analysis. So there are lots of engineers building models, training these models for the specific purposes of the companies and running inference on them. So as a data scientist, let's assume we have a data scientist background here. Why would we consider machine learning engineering? Our program does provide a much deeper understanding into developing, optimizing, implementing machine learning algorithms. So think of it as opening the hood, right? Looking under the hood to have a deeper understanding of how these algorithms are implemented. So if you want to go that route and actually work on the algorithms that drive machine learning, you could do that. A lot of the engineers would just use tools like TensorFlow and just use them as tools to do their analysis. That is fine as well. So we have a few classes that entirely focus on that. So that would make you, that will improve your programming and software development skills, right? And the third bullet is important. Once you have an idea of how to apply machine learning, how do you train the models, how do you sanitize data, how do you run inference in the models, machine learning engineers can be involved in product development, right? So in terms of looking at how a product is built by integrating machine learning models into them as well. So we have some, to give you an example, we have a few projects that have variables like your watch or like a Fitbit, any type of variables on your body, looking at the signals, right? EEG signals, ECG signals, blood glucose levels, but whatever it is that you measure, and you want to perform data analysis on what's called the edge. So right on your, let's say, wearable device to give you instant feedback as to what's happening. All of that now is machine learning as well. There's something called tiny ML. These are tiny machine learning models that we can put in these low-cost embedded devices that will do data analysis right at the source. So as a machine learning engineer, you can be involved in that kind of product development. And of course, the earning and growth potential for machine learning engineers is very high. The growth potential as more and more companies invest in AI. That's only we only expect that to grow, right? So those are some of the advantages that you're coming from a data science background to consider machine learning programs.
Just wanted to know a couple of more things. For all the existing or the former MLE students, what kind of job roles have they landed in? What are they currently earning? What is the potentiality of this field in America?
So we have, I can say, well, the standard places we have students who are placed in Facebook, Google. So those are, so Kapil put up the slide there. So those are some of the companies to where our students go to. Now, in terms of the companies that kind of focus on machine learning itself, you can see Comcast there, for example. So Comcast is focusing more on anomaly detection in their malware detection in their ISP provider. They're ISP provider, and they want to know if my computer, which is hooked up to their system, is infected, for example, right? And that kind of analysis they run using machine learning these days. We have some of the power companies like PJM there, Pico. So they are slowly starting to analyze, the stability of the grid performance using some machine learning. Then you can see Microsoft, SAP, and Google and Facebook. So those are the standard types of machine learning places. So, for example, if you go to Facebook, for example, and we have a faculty member who does this, you're looking at the authenticity of videos posted, right? Is it deep faked? If I give you a photograph, for example, can you tell me that somebody didn't copy and paste something from another photograph into this photograph and pass it off as a real photo? So there's a lot of multimedia forensics that companies that work in the area are interested. Comcast owns NBC. NBC Universal is a subsidiary of Comcast, and NBC. All of these media companies are very interested now in actually validating and verifying video content and digital content as well, similar to Facebook. Right? So we have students at Tesla, for example. Self-driving autonomous vehicles is a big thing, where you do machine learning for path planning, object detection. So every company is using machine learning to some extent in terms of their operations. Some of them, like if you see their Facebook, Microsoft, Google, those are very what do we call familiar names, right? That use machine learning. But a lot of the companies on the list also internally have machine learning groups that work on data analysis. I noticed a question. Is there a question for me? Somebody raised their hand. So that's how I would pose it. And also, there's a lot of interest in building hardware for machine learning, right? Because these machine learning tasks are very compute intensive. And they consume a tremendous amount of energy these days. So there's a lot of interest. For example, you see NVIDIA on the list there, for example. NVIDIA systems are the kind of the workhorse of training these machine learning models. So there's a lot of interest in making the hardware itself efficient to be able to train these models in more energy efficient fashion. So there's a lot of areas where people are working on.
Got it. Well, I think for all of you who would like to know more, you could take a quick picture of the slides so you know which industries are willing to recruit. But like Dr. Nagarajan was mentioning, machine learning has become very ubiquitous in its need in general. And with data becoming a fuel for all companies and their growth engines, I think machine learning is an absolute fit, because we're now moving to a hyper-personalized economy. Everything is tailored and bespoke. And for AI to achieve its full optimization, we need to know how do humans interact, behave, respond. And that's something that makes machine learning indispensable. So what this graph or what this picture, what this illustration is evidently speaking of is the kind of demand it has was the defense sector, the ICT sector, the consulting firms, tech firms. You've got every kind of firm here: financial, health, mechanical, energy, hardware. Dr. Nagaranjan, one of my questions to you is an ML engineer, is the skill set of an ML engineer different to someone who's done a very theoretical MSAI in terms of the deployment of ML in machines?
Kapil, can you go? Yes. So that's an interesting question. And it is somewhat different from if you're asking what is the difference at a high level between artificial intelligence and machine learning. Now, machine learning is building models for inference and for regression, for prediction, whereas artificial intelligence is a more a high-level goal of making machines as intelligent as human beings, right? So machine learning is a more specific goal of trying to model a learning architecture to the input data for the purposes of that architecture once trained, providing predictions and classification, right? So it's kind of a sub area of artificial intelligence, but not as theoretical. It is very applied, right? So if you look at the classwork here, so how we've structured it is we have what we call foundations of machine learning engineering. So as I said, the difference between machine learning engineer is that we like our students to also know what's happening under the hood. Now, whether or not you use it, that's a different issue. Now, there are people who want to build machine learning tools like TensorFlow. There are developers that work on that, but a lot of our students also just use TensorFlow as tools, right? So we cater to both. So we have what we call the foundations of machine learning engineering, which would be basic probability, right? Basic analytical methods for data analysis, ideas such as reinforcement learning. ECE 610 is what you would normally think of as like a theoretical machine learning class, right? Because that's going to talk about the algorithms that are being used by the machine learning tools themselves. But then we also have machine learning development, which is more practical. So ECE 612 is a very popular class that we have in our program. So that requires very little probability background, right? So that would be something that your students can come and immediately take, right? So in some sense, all it requires is some Python programming knowledge. And the idea is to show students how easy it is. It's a fully project-based class. So the instructor covers everything from natural language processing to large language models, to GANs, to multi-agent systems, all in the context of like 7 or 8 projects, right? And the idea is to show the students how easy it is to use these tools in a few lines of code, right? You can import data, you can import the model, you can train the model, you can infer from the model to give the students an idea of the usability of these tools. Once they would take, so the idea would be once you take that course, then you can take a little the 610, for example, which is a little more in-depth class on what are the algorithms that the machine learning systems use, right? So once you have the foundations, then you have a lot of these applications of machine learning engineering. So this is what, as I said, every company, it doesn't matter if it's a big like Facebook or Google, almost every company that I know of has some aspect of machine learning in their operations. So we cover, I think, a fairly interesting variety set of applications. For example, applied robotics lab is something similar to think of it as autonomous robots, right? The robots obtaining data from camera, LiDAR, processing it using machine learning algorithms and navigating their way through a environment, right? That's like a self-driving system. As I said, Philadelphia is big for health sciences. There's lots of, there are many hospitals here, big ones. So cell and tissue image analysis, if I give you a image of, let's say, a detection of breast cancer or prostate cancer or any of the image analysis style problems, are also people are starting to apply machine learning. Multimedia forensics, give you a photograph or video. Can you tell me what its authenticity is? Bioinformatics, genomics, machine listening and music is interesting. People who have used Spotify, for example, right? It will learn from your listening preferences and start the machine learning algorithm. It's called a recommender system, but that's what Netflix uses. That's what Spotify uses. It's what every other company uses to learn your preferences and start, recommending things, what it thinks that you're interested in, right? So that course kind of covers that, and of course, computer vision. So those are the applications of machine learning engineering covering these various fields, right? And then for the students, I don't know if this is relevant to your students. Hopefully it is, but this requires a little bit more computer engineering background. The last box that you see there, which is called hardware for machine learning. So if you do have a computer engineering background and you know a little bit about computer architecture, then you can talk about, okay, how do you build specific processors that are very specifically oriented towards speeding up, these machine learning workloads. This is also very popular among our students. So because lots of companies are very interested in building specific hardware rather than general purpose hardware for machine learning workload. Right, so that is that's in a sense what you would get in a machine learning engineering program that we have.
Now, most of these modules that you have towards the right side, what are the modules that would be covered in the machine learning engineering course and not a typical MSAI course, right? Because this is more.
That is correct. That is correct. These are very application specific. It's not high level discussion of AI and stuff like that. Yes. So that would be different from what you would get in a typical AI class.
What I can also see is there's a lot of bioinformatics and biology or let's say microbiology components to it, and then we go there. So how vast and extensive is the automation or applied robotics side of this module? So would this stretch to 10 weeks? Would this be longer? For someone who's looking at automation, robotics, and applied machine learning in that way, we're going to be using the hardware for machine learning and the applied robotics laboratory. Both of these would contribute to the automation side of when we're deploying MLE in hardware, right?
That is correct. So we do have a program called on robotics and automation. Now, I would automation is a large field. I would break it into two. Right, the one is the locomotion itself, motion of, let's say, I want to build a biped robot, and the robot walks like a human being. Right, so that's a control theory aspect to it. So the locomotion, and then cognition is where machine learning would be used. So the robot has to understand where it is in its environment, has to plan a path from point A to point B, right, and has to go from point A to point B while avoiding obstacles and detecting objects along the way. So that's at a high level what cognition is. So the machine learning would be applied at the cognition level, right? And then at the locomotion level, you need to know a little bit about control theory. So as a roboticist, you can choose to focus on one or the other or both. So some of our students do both, but you can focus on just the computer vision system, for example, right? Object detection, path planning, or you can focus on the control theory. But control theory is more electrical engineering field. So for the applied robotics laboratory, we provide the robot. So you're not building the robot itself, right? So the robot is there. You can control the robot. So essentially, you're building a cognition system on top of the robot to have the robot, like it's something called simultaneous localization and mapping, SLAM. So the robot needs to figure out where it is in its environment, right? Localize itself, and it needs to know where am I going, and what are the items along the way that I need to avoid or plan my path around. So it is a 10-week class, and it is entirely lab-based. It's a project-based class. Now, if you look on the foundation side, the same person is also teaching a little bit more theoretical class called reinforcement learning, right? And there are classes on decision-making under uncertainty and things of that nature. But you're right. So at the robotics level, if you wanted to apply machine learning, it'll be mostly at the cognition level. So like looking at a scene and making sense of what it is that the robot is seeing.
Got that. And so back to what I asked you in the last 5 minutes. So, how much earning potentiality is in this field? And I just want the attendees to realize through you that how huge is the AI ML industry going to be in the next 5 years? How enormously big is it going to be, and what is the potential it offers versus a typical software engineer in the United States?
My personal feeling is every company that can use machine learning or is able to figure out how to use machine learning for data analysis will use it. Right. There's a lot of potential for automation. I think self-driving cars are just in their infancy at this point. Right? So there are things like self-driving vehicles, autonomous vehicles, drone technology. So there is a lot of potential to start putting in these machine learning algorithms into those areas as well. But at a high level, every company that can use, even accounting companies, for example, right? So they're all looking for, it is pattern recognition. At a fundamental level, it's pattern recognition, as you see there in the class 687. And if you have data and you want to recognize patterns in the data, then you will, at the minimum, explore the use of machine learning. And if you can find good models, you will use it. I mean, every company already uses it. The credit card companies use it for fraud detection.
Yeah.
Right.
Yeah, I'd agree with that also. I mean, we've seen that in a number of our graduates. And I think even if you look at some of the application classes that are listed here, it's even a bit of an undersell, right? I mean, because we have, as Professor Kandasamy said, faculty or graduates who end up taking what they learn in engineering and machine learning engineering and work in finance, right? Looking at how do you use machine learning and pattern classification to enable micro trading, or how do you use it for different financial applications like fraud detection? I teach a class in wireless communications, and even the telecommunications industry is also looking at this too, right? We've developed radios that are capable of learning how to improve their communication performance, and even though it's not listed as a class here, it's something that the students could take. Almost all engineering disciplines now are embracing machine learning engineering because of what Professor Kandasamy was saying, that the employers are really looking for people with this skill set, not just to kind of run the same 5 lines of code they pull down from Stack Exchange, but to understand the entire engineering design process, to understand how ML fits in as a tool with other tools to solve real challenges in different areas. And I think you'll see that increasingly, in the way that our students are employed.
One of the other things I wanted to gain more intelligence on, and I'm sure it'll benefit everybody viewing this, could you list down the major difference, or can we juxtapose virtually AI, machine learning, and deep learning? And what are the stages? And what kind of interest does each one of this feed?
I can try to answer that. So AI is think of it, if it's machine learning is a subset of artificial intelligence, right? So when artificial intelligence came out, people wanted to make machines as smart as human beings, right? So it's called a common sense machine, or a machine that would pass the Turing test. That is the goal. I mean, ChatGPT might actually pass the Turing test at this point. Who knows, right? But that is the overall goal of AI, is much ambitious. It's artificial intelligence broadly defined to build machines that are as smart as or smarter than human beings. Machine learning is a little bit more constrained. As I said, it is learning from data to be able to build models that make predictions for the future, right? So it is a subset of AI, but it's more applied, and it's very focused on those specific problems, right? It's trying to solve. And deep learning is a part of machine learning. So what deep learning simply is that these architectures are fairly deep in their structure. They're not shallow learning architectures. Nowadays, because we have so much processing power, right? That's why people are building all of this hardware for machine learning applications. We have a lot more hardware, processing power that you bring to bear on these machine learning models. So deep simply means that if you look at the model, like I think some of your attendees may know, like a VGG model or a deep net model, these are very deep models. They have 20 plus layers in them, right? And each layer does some processing, and then forwards its data to the next layer and so on and so forth. So that's where the term deep comes from, right? So when neural networks first arrived on the scene, they were shallow. Maybe there was one what we call input layer, one hidden layer, one output layer. There's 3 layers, right? And they're what we would call the learning capacity is limited. So people can show that the deeper these networks get, the more they can learn, or the more precisely they can fit to a much more nonlinear function. So the complexity of the functions that they can learn will increase as the depth of the architecture increases as well. So some of the large models are very deep, so that's why it's called deep neural networks, right? But the trade-off is the deeper it is, the more training needs to be done, and the more data needs to be provided to it, and the more processing needs to happen, which now with modern GPUs and other hardware, people can do it. So I would think of AI as the broad umbrella under which machine learning resides, and then deep learning is architecture inside of machine learning. So you can still use shallow architecture, but the people start using deeper and deeper architectures because they have better learning capacity.
So essentially, is deep learning intended, or is it designed in a way that it can mimic the human mind and sort of pursue a non-linear approach to how we can build or deploy artificial intelligence into into any domain or into any function? Yes,
it is quite possible. It is possible. I mean, we don't know where the future is heading. It is mimicking. It's not. Yeah, there are architectures that are now attempting to mimic the brain itself. So, for example, if you see 613, which is called neuromorphic computing. Down on the bottom box there is ECE 613, right? It's called neuromorphic computing. So the people have started also building neural networks. They're called spiking neural networks. And these networks attempt to mimic what the brain does. In other words, how does the brain process information? And our brains process information in terms of spikes. So they just send out these spikes between neurons over synapses. So there is work now that is trying to model how the human brain itself behaves. And there are architectures that claim to simulate, millions of neurons. Right, so millions of neurons that are connected like they would be connected in your brain. Right, so it is not running through a typical computer. It's called a neuromorphic processor. So you're trying to even model how your brain behaves. So the future is honestly, nobody knows what the future holds, right? But all we know is these models will get more and more complex.
Got that. Sorry if you were saying something.
Yeah, the models will get more and more complex, and they will, at some point, it may be that if you talk to ChatGPT version 7, there may be no difference between talking to you and talking to a chatbot.
Sure, yeah.
No, right. So, and that's so there are people who are concerned about it as well. Maybe we're going too fast, maybe we have to slow down. But once the genie is out of the bottle, there's no way to put it back in there. But there are people who are concerned a little about the speed at which these things are progressing.
Got that. One of the other important things that I want to pick with Dr. Dandekar is letting all our attendees know the contrast between a regular applicant at Drexel and someone who's coming through upGrad. One of the things that I want to let the attendees know is for upGrad, we're now recruiting with a computer engineering or IT or BCA degree. You do the triple ID Bangalore or advanced certificate course in DS, where you do intensive modules of data engineering, machine learning, advanced machine learning, NLP, deep learning. You do 600 hours, 8 months of coursework. Then you move with 9 credits to Drexel. Your cost comes down from $57,000 or $58,000 down to $33,750 with upGrad and Drexel's unique scholarships that we've introduced. I'll give and hand over the baton to Dr. Kapil to introduce more on how does the upGrad model actually work and how does this kind of accelerate your pathway to Drexel.
Sure. Yeah, sounds great. Yeah, so I'm happy to answer that. So we have, these as part of the certificate that you just mentioned, we have worked very closely with our colleagues at upGrad to develop transfer pathways into our program and spend special pricing for people who are participating in the program. You can see here a list of the various courses that we will accept as transfer credits to our program. We'll accept that as 9 quarter credits of transfer to our program. And essentially, when you applied through the program, which is a process I'll discuss in a couple of slides, you'll have to fill out some paperwork that will essentially specify that these classes are here and that we will transfer them as electives into our program. So this is something where our curricular team kind of met with our colleagues in upGrad, and we essentially worked out what these transfer pathways would be. And essentially, this is saving you 1 quarter's worth of time in our program by having this accelerated pathway. Now, if you want for the actual application process, how this would really work. We'll be working with our colleagues in upGrad to manage the application process. You'll be able to apply online using our online application. We will waive the application fee as part of the partnership that we have here. And the deadline to apply for the winter term start in early January 2024 would be October 1st, 2023. So you can go through and work on that application process, working with upGrad and working with our team. Sherry and Cookie are both here as well if you have any questions about the application process. Once you are accepted to the program, you'll receive a notification in the student portal. You'll be prompted to make a deposit to start the I-20 process. And you'll essentially then be contacted by one of our program advisors to welcome you to our program and start working with you on on the plan of study. And we really look forward to welcoming you at the start of January. Let me just say a bit about what is required in the application. We're looking for a completed online application form. What we are generally looking for students for a graduate program to engineering is a Bachelor of Science degree in engineering or sciences from an ABET accredited institution or equivalent international institution. If you're coming from a background that may not be engineering, but is engineering adjacent, computer science or other types of disciplines like that, we can certainly work with you to see what your background and interests are, just to make sure that you're a good fit for the program. What we generally are looking for is a cumulative undergraduate GPA of 3.0 or above. But if you are below this threshold and you have significant industrial experience, which I believe all of your applicants would, this is something where we consider the entire application, right? If you got your degree many years ago and you've been working well at a company and you have good recommendation letters from there, that's something that we would take into account. We do need official transcripts from all universities or colleges that were attended, letters of recommendation. This could include someone who's a former professor in your undergraduate, or if it's been a while since you've been in the classroom, it can be someone in a supervisory position to you in your workplace, your resume, and then standardized tests. We are currently GRE optional, and as long as English was the language of instruction for your undergraduate program, there are no standardized English tests required as well. And then we also look for a statement of purpose in the essentially an essay as part of the application, and that's really just to describe what your background is and what your interests are in going through our program. If you might be interested in discussing potential research or thesis as a part of the machine learning engineering degree, you can talk there about what interests that you might have. But essentially, we're just trying to get a sense of what your background is and what your interests are to see how you would be a good fit for our program. So really, that's all there is to it in terms of the application process and getting started in our program. And certainly, if you have any questions about that, you can reach out to our colleagues at upGrad or reach out to us, and we'd be happy to help you get the application rolling and have you start with our program in January.
Thank you, Dr. Kapil. Is there any question that you have? If you do, feel free to put it on the Q&A button, but I think this has been a wonderful session, and I've personally learned so much about what this industry holds as a possibility. What is the difference between all of these confluencing technologies that are now emerging, but also I think more importantly, the kind of rising demand across domains that we've got with the IML, and what would it do to someone picking up this domain, and not a regular mundane computer science or electronics engineering masters. So with that said, I don't think we've got any more questions. I'm still going to put my email address down for everybody. My colleague Arushi has also sent a message for you to browse all our courses. Now we're live with the Drexel courses on machine learning engineering, MS and MS engineering management. Now that we're live, we're inviting applications. You go to Triple ID first, it is online, and then you finally move to the United States. With Drexel, you get a dual certification. Plus, I think you get an advanced academic readiness, and you get 9 credits of waiver at Drexel. So you make an advanced entry into the course anyway. But I think even important is that your chances of succeeding at the outcomes or the courses is so much higher than a regular student. Dr. Kapil, Dr. Kapil, Pookie and Sherry, it's been an absolute honor for us to host you guys. Anything that you'd like to cover, and then we'll call this a night.
No, I see some questions in the chat about courses to get into AI ML. I believe we answered those questions with the classes that we would transfer. And I guess there was a question about how this recording of the session, if that would be distributed. So I believe the session is being recorded, and
Yes.
that's something that you could certainly share with the attendees. So yeah, that's
attendees. Our team will in fact send you the copy of the recording, and you may feel free to watch it at any point.
Well, thank you very much. We appreciate you hosting us, and we really look forward to seeing you all on campus in the winter. Thank you all.
If you have any questions, feel free to. I did put my contact info in the chat box there. So if you have any questions related to the program, feel free to send me an email. If I cannot answer it, I will forward it along to the correct person. It's in the department, so they'll get back to you. And thanks again for attending the presentation. Thank you, Praneet, for hosting.
I think they must have filtered out some time, pulled out at least 1 hour for us on a weekday, and this in fact means a lot. And I'm super excited that they're here. I'm keen, and I'm super confident that these are likely to be the next applicants for Drexel University. Siddharth says, can you tell me about the co-op and how to apply and cost of the program and how much can we? So Siddharth, the co-op is a part of the program. I can still go back to Dr. Dandekar and ask, what is it that they need to pay extra? But he's put down the range of your stipends and what you actually make if you were to be enrolled, but still more on this from him.
Sure. Yeah. I mean, so so this is you're not paying tuition when you're doing a grad co-op, and typically these are paid experiences with the salaries that are shown here. The co-op preparatory class that I mentioned, co-op 500, which essentially teaches you how to manage our career development system and get matched or to find co-op employment, that's a 0 credit class. So that actually doesn't have any cost, separate costs associated with it beyond the rest of the tuition in the program. So yeah, I mean, there are lots of resources that are available. And our Steinbright Center can help you with that. You know, so here are some of the services that they would provide, you know, that I mentioned, where they do interview preparation. They'll help you with your LinkedIn profile. They'll critique your resume, tell you how to use our virtual and in-person career fairs, and conduct a job search. And this is obviously good for your cooperative education employment, right? It's not guaranteed. It's something that's really driven by the student using the many resources and the training that we provide. But it's obviously also something that you can use for your full-time job search, right? That when you're kind of building up all of these skills and these connections, you use it for the co-op search, but then you can also use it for your full-time job search. And you know, we do very well in terms of having our students be employed once they're done with our programs.
Perfect. I think with that, we're at the end. So I think this has been a good one. I will put forth more questions from these students to you, Dr. Kapil, Dr. Nagaranjan, over time. But for now, this has been an extraordinary space. So much to learn. Thank you so much. I'm hoping you guys have a long day ahead of you. Thank you so much for being here. And we'll make sure that we put more applications for you in the coming days. But I'd implore all of you to research more on Drexel and the concept of co-op and the fact that Drexel is the second best university across the United States for its co-op programs. Now that means something. So I want you guys to research, especially for engineering at Drexel, and hopefully we should be hearing from you soon. And our counselors will be in touch. You should expect to hear from them. Thanks, everybody. Thank you.
Thank you.